إذا الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا مغانيها.
Assalamu alaikum and welcome to the ITV Math Show. I am your host and presenter, Mohammed Kota, and we are shooting here live in Johannesburg. Now, firstly, before we get cracking with the show, I'd like to say thank you to everyone who's purchased all our DVDs, as well as all those who have been sending phenomenal amount of compliments on the email to say how much you guys have enjoyed the show during Ramadan. Now remember guys, this is the post-Ramadan programming and we are now preparing the grade 11s and 12s for the final exams this year. We've got a bumper planned schedule for 2015 where we're hoping to incorporate from grade 8 right up to grade 12 here on ITV. So ITV is the channel you need to be focused on. Your TV needs to be hooked on to ITV, logged on to the channel 347, and you need to make sure that you go onto the website as well, itvnetworks.tv, to see when is the ITV Math Show playing. Now, we ended up our first block with sequences and series, and we had a lot of in fact, the majority of the last 2 weeks of Ramadan's programming was only for grade 12s. We had a lot of suggestions. Mr. K, grade 11s, we need some help here. We need help with exponents. It's something we didn't touch yet. Now remember, exponents is a topic, so we're going to be starting today with exponents, guys. So, exponents is a topic that grade 11s and 12s need to know very, very, very well. Now, grade 11s, you know there are different types of exponents. There's surds, rationalizing denominators, and that's what we hope to include into today's show. If not, if we don't complete it in today's show, it will then flow over into the next show. So we're going to be starting with exponents. Grade 12s might ask the question on exponents, how important is exponents for grade 12? Well, in grade 12, you guys do know that calculus is a major component. And when you are doing differentiation, you have to use your rules of exponents in order to get your original function into a straight line, to get it linear. And there again, you'll be using your rules of exponents. So without any further delay, let's get started with today's show. We're doing exponents, grade 11s and 12s. Make sure, now most of exponents will be without the use of a calculator. So put your calculators away, take out your books, take out your pens, and let's get started. I'm going to start from basic. Let's start with the rules of exponents first. Now, we know, let's put down our rules. Let's put down our rules here on the side. So let's make a nice big rule box here. Please make sure you learn these rules. Right, when you multiply and bases are the same, we add the powers. When we divide and bases are the same, we subtract powers. And I'll explain to you, we're going to be doing some examples of each of these types of rules, and then we're going to throw you into the deep end and give you some of the most hectic ones that you possibly could see in the examination. Okay, now, before I continue here with the rules, I just want you to remember that we're always going to be using prime bases. And what are your prime numbers? 2s, 3s, and 5s. You know that prime numbers are numbers that have only two factors, 1 and itself, like the number 2. There's only two numbers that can go into 2, 1 and the number 2. The number 3, only two numbers can go into 3, 3 and itself, 3 and 1, or 1 and itself. The number 5. Now, yes, there are other prime numbers, 3, 5, 7, 11, 13, but we don't go so big. The most commonly used ones will always be using prime bases. So even if a number is 4, it will become 2 squared. If the number is 9, it will be 3 squared. If the number is 16, won't be 4 squared, but it would be 2 to the power 4, because we're only going to be using 2s, 3s, and 5s. So, When we multiply and bases are the same, we add powers. When we divide and bases are the same, we subtract powers. When we raise a power, to another power, we multiply powers. Any base to the power 0 is equal to 1. Any base to the power 0 is equal to 1. These rules have been drilled by your teachers in your minds from grade 8. We are now in grade 11 and 12, so these rules need to be known on your fingertips. So when we multiply, we add powers. When we divide, we subtract powers. When we raise a power to a power, we multiply powers. Any base to the power 0 is equal to 1. Something to remember, okay, with surds, I'm going to do the rules of exponents and surds in the same block of rules. With regard to surds, right, if I have the cube root of x squared, and we need to remove this, because these are important concepts. You're going to see we're going to be doing application of these rules in these problems. So, if you have the cube root of x squared, to remove the surd, what would you say? Would you say x to the power 3 over 2 or to the power 2 over 3? It's to the power 2 over 3. Guys, you take your inside power divided by your outside root. Your inside power divided by your outside root. So your power is your, let's just put an arrow there, it's your inside power divided by your outside root. It's always inside over outside. Right? Inside power divided by outside root. So even if you had, so that's example number 1. Let's look at example number 2. If I told you the fifth root of x to the power 6, would that be x to the power 5 over 6, or would it be x to the power 6 over 5? We said inside power divided by outside root, so it's x to the power 6 over 5. The most commonly used one is just square root of x. Now square root of x, we know that the power inside here is 1, and because it's square root, it's 2. So this here would be x to the power 1 over 2, x to the power half. Not x squared, because x squared and the square root of x is not the same thing. So the square root of x would be then, to remove the surd, would just be x to the power half. And you know, with your rules of exponents, that you can never leave your answer with a negative exponent. So your answer, so let's just make this rule box a little bigger. Your answer will always be with positive powers. You've got to leave your answer with a positive power. So even if you get a negative power at the end, you'll have to convert it and make sure that your answer has got a positive power. So let's just quickly go through the rules. When you multiply and bases are the same, we add the powers. When you divide and bases are the same, we subtract the powers. When we raise a power to another power, we multiply the powers. Any base to the power 0 is 1. When we are removing a surd sign, we take the inside base and we say the inside power divided by the outside root. Inside power divided by outside root. And you always got to leave your answer with positive powers. So let's get started. I'm going to start you off with some basic ones, and we're going to be moving up to some very hectic ones. So let's start off with the basic one, example number 1. Right, I know you guys are now getting irritated on that side. You say, come on Mr. K, get on with the show. Let's get started with the problem. Okay, let's start off with the basic one, 1 over 8 to the power 1 over 3. Now what did I say? That's the question. Where are you going to start answering? Okay. What did I say? We always got to use prime basis. Now the number 8. Is the number 8 a prime number? Do you guys know what is the opposite? Let's see. Test your knowledge. What is the opposite of, or the complement of the word prime? If a number is not prime, what must it be? Do you remember that from grade 8? Composite. Composite means it has many factors. Prime means it has only 2 factors. So the number 8 is a composite number. It's got more than one factor. 1, 2, 4, and 8 goes into 8. So it's a composite number, not a prime. We need to get it to prime. We need to get it to the base 2. So this is going to be 1 over 2 to the power. Now the number 8, we know by now it's 2 to the power what? 2 to the power 3. Good. 2 to the power 3 to the power a third. We know now to raise a power to a power, 1 to the power a third is still 1 over 2 to the power. We raising a power to another power. Watch here, guys. We raising a power to another power. What do? We multiply. So 3 times a third. I'm just going to write it in. In the exam, you don't need to write it in. You can just use your calculator or you can do it mentally. So I'm just going to write it in. 3, there's your 3, times a third. Because we're raising a power. Now we know 1 to the power a third is still 1. 1 to any power is still 1. This is equal to 1 over 2 to the power. 3 times a third is 1, and 1 over 2 is a half. And there we go, boys and girls. Quite easily done. That's your final answer. You'll get 2 to 3 marks. Now, obviously, in grade 11 and 12, you won't be getting this as an independent question on its own. This will always be integrated in other questions. But it's a process that you need to understand. Okay? So here we go. 1 over 8 to the power a third. Let's go, let's pick up the pace and let's go on to some more, a few more hectic problems. So now that you've got this one down, please remember something, just a point for you. Try and write your fractions over 2 lines. Don't try and squeeze it into 1 line. Remember, put your numerator on 1 line, divided by, put your denominator. The bigger you write, the better it is for you to understand in the exam. Okay? Let's go. Remember, I'm going purely into application. We're not going in order of the questions. We're not doing the multiplication problem alone. We're not doing the division problem alone. We are going through it all together. So, let's take the next example here. And we say, let's take the cube root of 2 over 3 to the power negative 2. Now we all know in a problem like this we need to remove the third sign first. We need to remove the third sign, and to remove the third sign, there's the rule. Okay, so now we're going to be cutting for an ad break. Now let's see whether you can apply these rules in order to solve this problem. Right, you've got 3 minutes. When we get back from the ad break, I will give you the solution. Stay tuned. Assalamu alaikum and welcome back to the ITV Math Show here on channel 347 DSTV, the only channel that you need to be locked into. Now, before we cut for an ad break, we started with the topic of exponents. I then gave you a problem to do, I gave you a question to do, and I said, let's see whether you can apply these rules to this to that question in order to get to the solution. So let's get started. Okay, in our first step here, we need to remove the third sign. So I'm hoping that by now some of the parents already, some parents have already started watching our show and enjoying it so much and started following our show. Now remember, if you guys want to watch any of the reruns of the previous episodes, okay, and if you want to upgrade your mathematics skill. I know there's many of you, some parents who want to do rewrites, or some learners or parents that have missed some of our previous episodes. Please go on to itvnetworks.tv, go on to the KY icon on the top, double click on it, double click on the icon, and all the previous episodes will then come up. So let's get started. 2 over 3, the cube root of 2/3 to the power minus 2. So the first thing we do is we remove the third sign. So we've got 2 over 3 to the power. I said, what's the rule? Inside power divided by outside root. So inside power divided by outside root minus 2 over 3. Now we know that everything in the brackets is raised to the power. So it's 2 to the power minus 2 over 3 over 3 to the power negative 2 over 3. Okay, what we're going to do now is we need to swap it over. We need to write our answer with positive exponents. So this will be 3 to the power 2 over 3. This comes to the top, over 2 to the power 2 over 3. Boys and girls, as it stands, that is your final solution. There isn't anything further that you can do with this. It's 3 to the power 2 over 3 over 2 to the power 2 over 3. There isn't anything further that you could do with this problem. Unless, it's quite odd that a problem like this was given. Now remember, we've taken this problem. How this problem would have been better, I'm just now restructuring the same problem so that we get a better result. If we said 8 over 27, I would say the better question would have been 8 over 27 to the power minus 2. Let's see. Let's try the same approach to that we used here. Let's try it there, and let's get a more interesting problem out of it. So this would be 8 over 27 to the power minus 2 over 3. Now we said that we need to bring them to prime bases. The number 8 is 2 to the power 3 over the number 27 is 3 to the power 3 to the power minus 2 over 3. That looks so much better. That looks like a more interesting problem to give, because here, I mean, you're still leaving your answer, it looks too odd. The answer looks too odd. But the answer is correct, by the way. So, this now would be 2 to the power 3 times. Remember, we are raising a power. We're raising a power to another power, so we are multiplying powers. We're raising a power to another power, so we are multiplying. So 3 times minus 2 over 3, the 3 and the 3 would cancel, you'd be left with negative 2. Over 3 to the power 3 times minus 2 over 3. Again, the 3 and the 3 will cancel, you're left with negative 2. Now, 3 to the minus 2 will come up as 3 to the plus 2. 2 to the minus 2 will come down as 2 to the plus 2. 3 squared would be 9 over 2 squared would be 4. And that is a far more interesting problem or interesting scenario than the previous one that was given here. This, I would say, just leave out. In fact, rather use this one as your model. Okay, we are now going to be picking up the pace, guys. We're now going to be going on to far more complex problems. So this is still, we're now just doing a variety of problems or examples that you could see under exponents. Okay? So take these problems down and make sure, remember, by now you are rewriting, the purpose of these shows is to ensure that you rewrite your own study guide. I'm going to give you some of the most popular questions that are in the exams. And hopefully at the end of our series, you would have then compiled your own little study guide in which you are mastering the problems and you are mastering math our way. Okay, so let's go on to another problem. Let's pick up the pace here, guys. We now say, here's another example. I'm just doing, like I said, we're doing a variety of examples. 125 to the power 2 over 3. Now, again, 125, guys, to what base are we going to be bringing it? To a 2? No. To a 3? No. To a 5? Yes. So now, the number 125 is going to be 5 to the power 3 to the power 2 over 3. So this is equal to 5 to the power. We're raising a power to a power, so we are multiplying. Raising a power, so we multiply. 3 times 2 over 3. The 3 and the 3 will cancel. We're only left with 2. And we know that 5 squared is 25. And there we go, guys. That's your final answer. Let's go. Let's pick up the pace. Okay, I tell you now, 1 over 64 to the power a half. Now we know that the number 1 to any power is still the same. It's still 1. So 1 to the power half is 1 over, in fact, let's leave the half there. Let's bring the number 64 to a prime base. To what base are we going to be bringing it? To a base 2, a 3, or a 5? Base 2, of course. Now, 64 is what? 2 to the power what? 2 to which power will give you 64? We know 2 squared, 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 5 is 64. So 2 to the power 5 being 64 to the power half. Okay? In fact, no, 2 to the power 5 is 32. 2 to the power 6 is 64. Now, 1 to any power is 1 over 2 to the power 6 times a half is 3. That's 1 over 2 cubed is 8. Alright? Now, the most commonly used exponents, when you're bringing it down, before we do this, let me show you something. You can also take this down. You can also take this down. Remember, we're doing some rules. These are the most commonly used one. We know that 2 to the power 1 is 2. 2 squared is 4. 2 to the power 3, 8. 2 to the power 4, 16. 2 to the power 5, 32. 2 to the power 6, 64. 2 to the power 7, 128. 2 to the power 8, 256. 2 to the power 9, 512. 2 to the power 10, 1024. Now, these are the most commonly used ones. Now, in fact, you can learn from here up to here, up till 2 to the power 6. The other ones are used, but not as heavily as the top 6. That's in terms of 2s. Let's now go in terms of 3s, which are the most commonly used ones in 3s. So we've got 3 to the power 1 is 3, 3 squared is 9, 3 cubed, 27, 3 to the power 4, 81. 2s, 3s. What about 5s? Which are the most commonly used ones in 5s? We've got 5 to the power 1, which is 5, 5 squared, which is 25, and 5 to the power 3, which is 125, and 5 to the power 4, which is equal to 625. There we go, guys. You can take these down. You can take these down. And these are the most commonly used ones in terms of 2s, 3s, and 5s in exponents. If you know this, you don't even need to use your calculator in order to bring them to the correct basis. Okay, let's now erase these and let's do more examples. Now remember, the examples are going to get fairly tricky. Here's another example. I tell you 0,008 to the power a third. Now, you've seen this. I know you've seen this. Now, how do we convert 0,08? How do we convert 0,08? We know that we need to convert it to a fraction. So this is 8 over 1, 2, 3 decimal places is 1,000. 3 decimal places is 3 zeros to the power a third. We now need to bring it down to a prime base. So the number 8 is what? 2 to the power 3. So there we go, 2 to the power 3. Over the number 1,000 to the same power of 3 would be 10 to the power 3. Because we know 10 to the power 1 is 10. 10 to the power 2 or 10 squared is 100. 10 to the power 3 is 1,000 to the power a third. And this will equal to 2 to the power 3 times a third, 1, over 10 to the power 3 times a third, 1. We know 2 over 10. 2 goes into 2 once, 2 goes into 10 5 times, guys. That is your final answer. Let's put down another question before we cut for an ad break, guys. I'm going to give you 2 questions to do in 3 minutes because these can be done quite easily and these can be done quite quick. So, I'm erasing this. I'm hoping that you've taken this down. Okay? So let's go. Let's do another 2 examples. I'm going to put up 2 examples quickly on the screen for you. And let's say, here's one, 0,027 to the power negative a third. I'd like you to do this one during the ad break. And I'm going to give you one more to do. And let's say the cube root of 2 over 3 to the power negative 6. There we go, guys. We've got 2 questions to do. It should take you 30 seconds. If you're good, it should take you 30 seconds. Otherwise, take a minute, and we'll get back. After the ad break, I'll give you the solutions. Stay tuned to ITV. Assalamu alaikum and welcome back to the ITV Math Show with me, your presenter and host Mohammed Kota, here in Johannesburg. Guys, this is not a live show, right? So please, these shows will be uploaded on the website. If you guys have missed the previous segment or you've missed previous episodes, go onto the website. At least allow 24 hours for these shows to be uploaded onto the site before you go and review the site. Now, just before the break, we had a good laugh in studio here. Somebody mentioned from studio that you almost made a mistake with the powers. So just to tell you guys, hey, I'm not a calculator. I'm bound to make mistakes. But if you, the viewer, you are picking up a slight mistake, if I've added incorrectly, I've made any slight calculation errors, guys, it means that you're understanding math. So please stay focused and let us know what you think. If there was a mistake in any of the... We've gone through all the shows. I don't think there were any mistakes. But if there are, let us know. Right? Type on go onto the ITV blog site. Let us know if you've picked up any mistakes. We welcome all your suggestions, all your complaints. And like we always say, if you're liking the show, tell the whole world. If you don't like the show, just let us know. Okay, so let's get back to math. On a more serious note, you know, math is quite serious. We try and lighten it and try and create a good atmosphere within the studio. But in any case, back to math. Right, so here goes. We've got 0.027 to the power negative a third. We're now going to convert this. We're going to say 27 over 1,000. I hope you guys got that. To the power negative a third. Okay, I'm now going to just move this slightly down. The cube root of 2 over 3 because I need space to work on the top. Don't worry, in our next episode, we've insisted a bigger board be given. So don't stress. I know many of you say, sir, why don't you use a bigger board? It's coming. It's on its way. Hold your horses. Okay, so here we go. Let's get back to math. We say 27 is 3 to the power 3 over the number 1,000 is 10 to the power 3 to the power negative a third. So this is 3 to the power. Now, we're raising a power to a power. The 3 and the 3 will cancel. You're left with negative 1. So it's 3 to the negative 1 over 10 to the power 3 times negative a third, which is negative 1. Right. Because 3 and the 3 will cancel out. Can we have, what does the rule say? Answer will always be or must always be. Now, let's not say will. Let's use the word must. Always be with positive powers. So, can that be my final answer? No. You might ask, will I lose a mark if I don't write the answer with positive exponents? Simply put, yes. Okay, so 10 to the minus 1 will come up to the top as 10 to the power plus 1. 3 to the minus 1 will come down as 3 to the power plus 1. Remember, when you're swapping a base from numerator to denominator, the sign of the power changes, not the sign of the coefficient. Many of you make a mistake in the exam, and if they tell you 10 to the power minus 1, you go and write 1 over minus 10. How can you do that? That's one of the biggest errors that a grade 8 to 12 would make, because these are grade 8 concepts, guys. Okay, remember 10 to the minus 1 is not 1 over negative 10. The sign of the coefficient doesn't change. This here actually becomes 1 over 10 to the power plus 1. The sign of your power changes, not the sign of your coefficient. Okay, so now that we've got this one here, let's go on to the second one that I left you guys with during the break. Just to confirm, I think this is the third segment. We've got one more segment to go after this, in which we're going to be doing some more hectic exponents. Obviously, we're not going to finish the topic today. So, in our next episode, on Thursday's episode, we will then complete the rest of exponents and the rest of surds. So, we've got the cube root of 2 over 3 to the power negative 6. So now we're going to say this is 2 over 3 to the power, remember, inside power divided by outside root, minus 6 over 3, which is 2 over 3 to the power minus 6 over 3 minus 2. This will give me 2 to the negative 2 over 3 to the negative 2. This comes to the top as 3 to the plus 2. In fact, let's not move over to the side. Some of you might just do this in the exam. Right, we're going to continue moving down. 3 to the negative 2 will come up as 3 to the plus 2. 2 to the negative 2 will come down as 2 to the power plus 2. 3 squared, 9, 2 squared, 4. There we go, guys. My answer is positive, so I know I'm okay. In fact, my powers are positive, so I know I'm correct. Right? When you're done with the problem, you mustn't say, I think I'm right. You must say, I know I'm right, because I followed the right procedures. And that's what you guys got to tell yourself in the exam. When you are done, you mustn't say, oh, I think I got this right. I think I got 80%. You must say, I know I got 80%. I know I got my problems right. Because if you follow the right rules, you must get the right result. Okay, let's continue, guys. Let us continue, and it's going to get a little bit more sticky. Now, watch this one, guys. We now give you the square root of the square root of 0,0625. Okay, this would be the last one before we go on to the very, very, very hectic ones. Okay, so now we've got the square root. Okay, let's put the square root again, and let's sort that out first. So that would be 625 over 1, 2, 3, 4. So 1, 2, 3, 4 zeros, 625 over 10,000. This is equal to the square root of the square root of the number 625. Let's put it down here. The number 625. The number 625 is 5 to the power 4. Over. What to the power 4 will give me 10,000? Oh, yeah, 10,000. 10 to the power 4. There we go. So we've got 5 to the power 4 over 10 to the power 4. Now remember, the power out here is 1. This is the square root. So this is equal to the square root of 5 to the power 4 over 10 to the power 4 to the power. We're removing the third sign here. So it's 1 over 2. Remember, inside power divided by outside root. So it's 1 over 2. So this is the square root of. We now have 5 to the power 4 times a half. We're raising a power, so we multiply. 4 times a half is 2 over 10 to the power 4 times a half is 2. Now again, we've got one more third sign to remove. That's a square. That's a 1. So again, we're now going to go 5 to the power 2 over 10 to the power 2 to the power 1 over 2. I'm going to move over to the side because of space, guys. Right, so this is equal to 5 to the power 2 times a half is 1 over 10 to the power 2 times a half is 1. And we all know 5 over 10 is a half. And guys, that is our final solution. 1 over 2. Now there might be different ways in which you guys might be attacking it and getting the same answer. So if you use the different way, and as long as you showed all your different steps and you get to the same solution, obviously your answer must be correct. But obviously if it's a 4-mark question or 5-mark question, you cannot jump from question to answer in one step. Use your calculator and say, you know what, we've got these calculators and therefore my answer must be correct. Your teachers will mark it incorrect. They want to see that you've used you did not use a calculator, you simplified without using a calculator, number 1, and that they want to see that you've applied the rules step by step. Remember, mathematics is process, mathematics is structure. We are here to teach you how it's done following the right procedure. Okay? Let's now take another hectic example. Now these are the other types that you're going to see. So these were just simplifying exponents where you were just given one term. Let's look at a question like this. I tell you 2 to the power 2n minus 1 times 4 to the power n plus 1 times 2 over 16 to the power n. Guys, a question like this is worth, I would say, about 4 marks. Okay? We're going to do this one, and then I'm going to put on one more on the board, and then I'm going to leave you. We're going to cut for an ad break, and then you've got 3 minutes, and then you're going to come back for our last segment where we're going to be wrapping up the show. So please, guys, stay focused. So now we're going to break them all down to base 2s. So watch. 2 to the power 2n minus 1 times the number 4 is 2 squared to the power n plus 1. Remember, 4 is 2 squared times 2 to the power 1 over the number 16 is 2 to the power 4. 2 to the power 4, don't forget, n. Now, we need to remove the brackets. So this is 2 to the power 2n minus 1 times 2 to the power. We multiplied by both. 2 times n, 2n plus 2 times 2 to the power 1 over 2 to the power 4 times n, 4n. Let's look at our numerator. We're multiplying. We are multiplying and bases are the same. We add the powers in the numerator. In the numerator we add the powers. So it's 2 to the power 2n minus 1 plus 2n plus 2 plus 1 over 2 to the power 4n. Okay, so we now got 2 to the power 2n plus 2n is 4n. 2 plus 1 is 3. Oh, in fact, what you can do, minus 1 plus 1 will cancel out. You're left with 2. So it's 4n plus 2 over 2 to the power 4n. We are now dividing and bases are the same. So we subtract the powers. So it's 2 to the power 4n plus 2 minus 4n. Remember, numerator's power minus your denominator's power, which is equal to 2 to the power 4n minus 4n will cancel. You're left with 2 to the power 2. And we all know that 2 squared is 4. Okay, guys, we're now cutting for an ad break. I want you guys to take this one down, right? If you guys got the PVR, put your screen on pause or record the show. Please make sure you take this one down. You go through it over and over and over again until you've mastered it. I'll see you guys after the break. Assalamu alaikum and welcome back to the ITV Math Show with me, your host and presenter, Mohammed Kota, here in Johannesburg. Now, before we cut for an ad break, I gave you guys we did a problem. I did promise you that I was going to give you one more to do, but then I thought about it and I said, you know what? Take that one problem down, make sure that you master that one, because now we are picking up the pace. I'm now going to give you we're going to do another 2 or 3 examples of that same style of question. Okay, so here goes the next example. So we say 5 to the power 2n plus 1 times 3 to the power 2n minus 3 over 15 to the power 2n. Now guys, this is grade 10, 11 and 12. So if you're a grade 10 learner and watching the show, this is for you too. Now remember, we're going to finish up today's episode. This last segment before we close, we are finishing up exponents. The next episode is going to be surds, guys. So get all your notes together about surds and stay tuned to our next episode too. So now here goes. Let's start with this problem. We've got 5 to the power 2n plus 1 times 3 to the power 2n minus 3. There's nothing we can do with the 5 and the 3. It's already brought down. They are already prime numbers. Our issue lies with the 15. Our issue lies with the 15. So now, what do? We have 5 to the power 2n plus 1 times 3 to the power 2n minus 3 over. The number 15 is 5 times 3 to the power 2n. Our two prime numbers that give us 15 is 5 times 3. So now we have 5 to the power 2n plus 1 times 3 to the power 2n minus 3 over. Now remember, we raise each of these bases to that power. So it's 5 to the power 2n, 5 to the power 2n times 3 to the power 2n. Now we are dividing and bases are the same. So what do we do to the powers? Subtract. So what do I have? I have now 5 to the power 2n plus 1 minus 2n. Remember, your bases cancel, so it's now we're dealing with the powers. 2n plus 1. And it's always numerator's power minus your denominator's power. Times 3 to the power 2n minus 3 minus 2n. Right? Why minus? Because numerator's power minus your denominator's power. You're dividing, you subtract the powers. So it's 5 to the power 2n minus 2n will cancel. You got 5 to the power 1 times 3 to the power 2n minus 2n will cancel. You got minus 3. Can that be your final answer, guys? No. Can I have a negative power in my final answer? No. So what is this? It's 5. 3 to the power minus 3 will come down in your denominator as 3 to the power plus 3. Remember what I said? The sign of your power changes. So this is equal to 5 over 3 to the power 3. 3 cubed is 27. And there we go, guys. That is your final answer. A problem like this could be anything between 4 to 6 marks. Okay, let's do one more. One more example of this type. So I have 18 to the power n times 8 to the power n minus 1 over 9 to the power n plus 1 times 4 to the power 2n minus 1. Okay? Let's put this down and let's see. Let's get busy with this. Okay, what are our bases here, guys? The number 18, is it prime? No, it's a composite number. 18 is composite. 8 composite. 9 composite. 4 composite. So what do we need to do? We need to bring them all down to prime bases. Now the number 18. The number 18. There we go. 18 to the power n. Number 18 is 9 times 2. But is 9 a prime number? No. The number 9 brought down to the right base, to the right prime base, is 3 squared. So what are we going to do? Instead of 9, we say 3 squared times 2 to the power n. Times the number 8 is 2 to the power 3 to the power n minus 1. Excuse me. The number 9 at the bottom, again, 3 squared to the power n plus 1 times 4 is 2 squared to the power 2n minus 1. Okay, let's see. I'm going to have a sip of water. Let's see whether you guys can continue. Remove the brackets there, guys. Continue with the problem. Continue with the problem. I want you now in the next step to remove the problem. What is this going to be? Take out the brackets and let's see what do you get. Let's see. Back to war. So we have 3 to the power 2 times n, 2n, times 2 to the power n, times 2 to the power 3n minus 3, over 3 to the power, we multiplied by both, 2n plus 2, times 2 to the power, 2 times 2n, 4n minus 2. Okay, now we've got 2's and we've got 3's. We need to collect the like terms. We need to collect our like powers because we have the same basis. So start with the lower prime number first. Let's start with the 2's. So it's 2 to the power, so I'm done with the 2's, n plus 3n minus 3 times 2 to the power 2n over 2 to the power 4n minus 2 times 3 to the power 2n plus 2. We've collected, we've added our powers because the bases were the same. Now remember, only if the bases are the same you add the power. You got unlike bases, you can't add the powers. You leave it just the way it is. Okay, I'm going to move over here to the side. I'm sure by now you've taken this one down. Okay, so I'm just moving from here to there. Okay, so this is equal to 2 to the power n plus 3n, 4n minus 3 times 3 to the power 2n over 2 to the power 4n minus 2 times 3 to the power 2n plus 2. This is equal to 2 to the power 4n minus 3 minus 4n plus 2. Remember, numerator's power, because you are subtracting, you change both these signs. So plus 4n will become minus 4n. Minus 2 will become plus 2. Times 3 to the power 2n minus 2n minus 2. This is 2 to the power 4n minus 4n will cancel out. Negative 3 plus 2, negative 1 times 3 to the power 2n minus 2n will cancel out. You're left with negative 2. Both these powers are negative, guys. Both these powers are negative, so we need to bring both the powers down. So this is going to be 1 over 2 to the power plus 1 times 3 to the power plus 2. This is equal to 1 over, what do we have? 2 times 3 squared is 9, which is equal to 1 over 2 times 9 is 18. Now, it might be a lot of steps, guys. I mean, you're doing it in 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. It might be a whole page of calculation. Yes, you could have shortened it. You could have made it half the amount of space. But I've just done it exceptionally thoroughly with you so that you could see in every step what had transpired. So, just to recap, the number 18 is broken up into 3 squared times 2, the number 8, 2 cubed, 9, 3 squared, 4, 2 squared. Next step, we just removed the brackets by multiplying out the powers. We collected our like terms, we simplified it, now we divided, collected our like terms, that's it, and we made sure we wrote our answer with positive exponents. Okay, guys, I'm going to give you one more to do. Let's do one more before we wrap up the show. And here goes, guys. Let's take this one down. I tell you, 3x to the power minus 2 over 3x to the minus 2 to the power minus 2 over 3. And this is the problem that we're going to be using in order to wrap up today's show. Now, I hope you guys enjoyed today's show. I hope you've learned a lot, and I hope that you've taken down each and every problem. For those of you who have just joined the show or just caught the end of the show, remember, you can always get our episodes and all the repeats of the episodes or the reruns of the episodes on itvnetworks.tv. Click on the Kway logo. All the previous episodes will come up. You can then go through, post all your comments and watch all these shows. Okay, so let's go through it quickly. This here is 3 to the power negative 2, x to the power negative 2. Remember, we're raising both of them to the power negative 2 over 3 to the power 1, x to the power minus 2 to the power minus 2 over 3. This is equal to x to the minus 2, x to the minus 2 will cancel out. You're left with 3, that's your base, 3 to the power minus 2 minus 1 is minus 3 to the power minus 2 over 3. Now, we are raising a power to a power. We multiply. Negative times negative is a positive. The 3 and the 3 will cancel. We are only left with 2. 3 squared is 9. And boys and girls, that is our final answer. And that brings us to the end of our show, guys. Hope you guys enjoyed the show with me, your host, Mohammed Kota. Stay tuned to our next episode. And if you guys want to know when's the next episode playing, please make sure go onto our website, itvnetworks.tv. Check our next episodes. Our next episode that's going to be in mathematics is going to be on surds. So please, guys, stay tuned to ITV.
الأمجاد قد عظمت فللأمجاد بانيها ومن يسعى إلى العليا سيدركها بما فيها ويبني مجده جذلا فروح الفذ يعليها ليصبح همة تروي عن العليا